Okay, we're dealing with a problem here. Some of these like traveling bug problems. And in this case, the bug is traveling. It starts out at the point 23. It's there at midnight. By 3 a.m., it's at the point 65. And assuming it's traveling in a straight line, the question is, where will it be at 7:45 when the alarm goes off, which is really a reference to another problem that you'll be working on later. So, in order to figure this out, we've got to figure out first what are x and y as a function of t. So what rule are we plugging t into to get these x values and these y values? And once we figure out what that rule is, we'll just plug time 7:45 in, and that'll output an x and a y value, and we'll be able to see what that is. So let's take a look here. And we know that if we plug in 0, we get 2 for x, and if we plug in 3, we get 6. And that really is enough. If you recall, we see that our difference here is 4. We're going up 4. And our difference here is 3. So plus 3 plus 4. And so our equation for x starts out as 4/3 t. By the way, just as a quick note here, t equals 0 at midnight. Remember, our time in any of these problems isn't time of day or time of on the clock. It's always time since some initial starting point. And we chose midnight to be our initial starting point, so we give that the time of 0. So we look at our change in x and our change in t. We see it's 4, a ratio of 4 to 3. So assuming we're traveling at a constant pace here, rate, then the x-coordinate will change at a rate of 4/3 of a unit for every 1 unit of change in t. So our rule starts out with 4/3 t, but it has to be adjusted because this won't work. If I plug in times 0, I output 0, but I don't want to output 0. I want to output 2. So we'll need to adjust by adding 2. And if we check, this should work. See, 4/3 times 3 is 4, plus 2 is 6. So that works. So this is our rule for x. Our rule for y, see, y is increasing by 2 for every increase of 3 in t. So our rule should start out with y equals 2/3 t. But again, if I plug 0 in here, then I'll output a 0, but I don't want to output a 0. I want to output a 3. So I have to adjust our rule by adding 3. And we'll check to see it works with the second one. If I plug 3 into this rule, 2/3 times 3 is 2, plus 3 is 5, outputs a 5. Perfect. So now we have our rules for the 2. We just need to plug in 7:45. Of course, the problem with 7:45 is that that's the time on the clock. And we need to figure out, first of all, well, how many hours since midnight? That's 7 hours and 45 minutes since midnight, but I can't plug in 7 hours and 45 minutes in for t. But 45 minutes, if I look here at the clock, okay, 45 minutes is 3/4 of the way around. So 7 hours and 45 minutes, 7 hours, 45 minutes is really 7.75 hours. Okay. So let's plug that in. So we have our x output, and I'm going to put 7.75 here. And let's see. So we have x equals 4/3, 7.75 plus 2, and 7.75 is like 7 3/4. So you could turn that into a improper fraction if you wanted to, but the calculator should be able to handle everything here. So let's go 7.75 times 4ABC3 gives us 10 and repeating 3. Let's do it as 7 ABC 3 ABC4 times 4 ABC 3/4. That's going to give us 10 and 1/3. So x equals 10 1/3, or we could also write that as 31/3. Okay, I like the improper fraction is usually easier to work with as a number mathematically, but 10 1/3 will be easier for us to find on the graph and plot. So the y-coordinate, y equals 2/3 times, let's see, let's just take a look here. Clear. 7 ABC, 3 ABC, 4. So 7 3/4. I'll turn that into, that's 31/4. So you can see here, this is going to end up, we multiply these two together, the 2 and the 4 like partially cancel, end up with 2 down here. We're going to have something over 6. So multiply this times 2 ABC3. I get 5 1/6 plus 2. That's 7 1/6, which is second ABC. Same as 40/36. You know what? Check over here. I can't remember if 7 ABC 3 ABC 4 times 4 ABC 3. I didn't add the 2 plus 2. 12 1/3. Which is, I think I caught that, huh? 37/3. All wrapped up in that decimal versus fraction thing and forgot to enter it. So we have 12 1/3 over and 7 1/6 up. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and a little bit more. And then 1, 2, 3, 4, 5, 6, 7, and just a pinch more. So we'll be at the point 12 1/3, 7 1/6. 12 1/3, 7 1/6. So again, just to go over the problem, we knew the bug was at time 0 at the 0.23, and then at time 3 it was at the 0.65. We wanted to know where would it be at 7:45, so we had to start out by figuring out what was the function that was determining our x and y coordinates. So we had to write our rule by first looking at what was basically the slope of this relationship between t and x. So what's the change in x with respect to t and change in y with respect to t, which is kind of like a slope calculation. That told us what our initial rule was, or kind of our starting point rule, but that always has to be adjusted by either adding or subtracting to give us what our actual outputs are. Once we knew the two rules, we just had to turn 745 into a decimal or fraction, and then plug that in for a time and output our location in separate x and y coordinates. And that's where the bug will be at 745.